Okay, we're going to go through exponential functions, change of base formula, and kind of a review of logarithms. Okay. The first thing the author talks about is the exponential functions. Okay, so let's look at that. And it's telling you it's a function, so the exponential functions, the graphs, pass that vertical line test. The author will give you equations like this to graph y equals 2 to the x power. It's an exponential function, so the variable's up as an exponent. Okay, so on your calculator, graph 2 to the x power. Go back to function mode and just put in 2 and use that caret symbol and raise it to the x power. So in y sub 1, it's going to look like this. 2 and then that caret symbol and raise it to the x power. Now let's just do zoom 6. Okay. And you should have a graph that looks something like this. Okay, and this would be our y equals 2 to the x power. Okay, now graph in y sub 2, graph 3 to the x power. So if we did 3 to the x power. Okay, and can't see that very good, so I'm going to go to zoom decimal, zoom 4. Here's the first one. Okay, it comes underneath it. Okay, so this one, it kind of comes underneath it. Still crosses right here, and it comes on the inside. Okay, so that's the y equals 3 to the x power. Okay, and then let's graph y equals, let's do 5 to the x power. Okay. Okay, same thing, it kind of comes underneath it, doesn't touch that. My pencil lid's too big. Okay, but it comes something like that. Now, every one of those goes through this point. What ordered pair is that? 0, 1, right? Okay, now if you think about that, you'd have y equals 2 to the 0 power, y equals 3 to the 0 power, y equals 5 to the 0 power. Anything the 0 power is 1. The only exception is 0 to the 0 power is undefined. That's why all of those are going through that ordered pair. Okay? Now, turn off the, actually delete those, and they are functions. The original one is a function. Okay? Turn off the, or delete the second two. Leave the y equals 2 to the x. Okay? So you'd have one like this for y equals 2 to the x power. Now I want you to graph y equals 1/2 to the x power. You can either put in 0.5, or if you put it in as a fraction, put it in parentheses. 1/2 and raise that to the x power. Are these two graphs inverses of each other? So you graph it. Here's the original. Okay, and here's the other one. Y equals 1/2. This one would be the y equals 1/2 to the x power. Are those two graphs or equations inverses of each other? How do you tell graphically whether or not you have inverses? They have to be symmetrical about which line? Y equals x. Are they symmetrical about that line? No. So are they inverses? No. You should be able to look at a graph and say, is it an inverse? Here's the line. The line's y equals x. If I fold that first graph over that line, is it going to lie on top of the second one? No. So y equals 2. A lot of people mistake these two. And y equals 1/2 to the x power. These are not inverses. And because they are not symmetrical, about the line y equals x. You ought to be able to look at it and say, no, they're not inverses. Okay? Okay, then draw a little separator. We're going to go back and review a little bit from the pre-calc. You should be able to, and this is good review like for down the road if you take ACT tests. You should be able to go from exponential form to logarithmic form. You did a lot of radical form in Algebra 2. The trig and pre-calc, we did some of this. But let's go back and review it. In exponential form, I can say 10 squared is 100. Okay. In logarithmic form, okay, it's the log of the number. The base is written as a little subscript. And remember, a logarithm is just an exponent. If you forget everything else, a logarithm is just that exponent. Okay? If I said 1,000 is 10 cubed, I would write it the log of 1,000. Base 10 equals 3. If it's base 10, you don't have to show this. Base 10 logarithms are called common logarithms, and they'll use like the log. And on the calculator, remember on the calculator you just do like log of 100, you'd get 2. Log of 1,000, you would get 3. Okay? The log on the calculator is base 10. Now, here's probably the most important part of this. The notes on this is if we had something like this, 2 to the third power, 2 times 2 times 2 is 8. Now if I go to logarithmic form, it's the log of the number, log of 8, base 2 equals 3. But if I type in log of 8 on the calculator, I'm going to get an error because the calculator is doing base 10. So here's the part. This is probably the most important part of this set of notes. It's the change of base formula. The change of base formula. It's the log of the number, the log of 8, divided by the log of the base. Okay, so try that on your calculator. It's the log of 8, close the parentheses, divided by the log of 2. Okay, and you will get 3 for an answer. Okay, so you probably want to say it, it's the log, I always say it, the log of the number divided by the log of the base. So if it's something other than base 10, you got to put it in that way, using that change of base formula. Okay, I would, if I was you, I would highlight that. Do you remember going through that last year? Yeah, but it's been a while. Okay. Okay. The next set of notes, the next part is on review. We did this last year also, but it's good to go back through it. The laws of logarithms and the laws of exponents. They parallel each other. Okay, there are 3. Okay, the first one, if I have x to the m power times x to the n power, when you multiply monomials and the bases are the same, what do you do with the exponents? Add them. And the base stays the same. The base does not go to x squared. Okay, the base stays in x, and you add the exponents. Okay. Okay, so like if I had 2 to the 5th times 2 to the 3rd, it would be 2 to the 8th. Okay? They parallel, laws of logarithms parallel those laws of exponents. If I have the log of, and this author uses, I think, the letter R and the letter S and base A. If you multiply, if you take the log of a product, you add their logarithms. The log of R base A plus the log of S base A. So if I said, what's the log of 5 times 3? And I'm going to use base 10, so you don't have to write it down. If you multiply the numbers, what do you do with the logarithms? You would add them. So it's the log of 5 plus the log of 3. You have to put those parentheses in there. Okay? And you can try that on your calculator. This is just kind of review. The second law, if you take two monomials with the same base and divide them, what do you do with the exponents? Subtract. The base stays the same, and you would just subtract the exponents. So like if I had 5 to the 7th power divided by 5 to the 4th power, the base stays the same. A lot of times people miss this on, I know, like compass test, ACT type test. People will say it's 1 to the 3rd power. They think those 5s divide out. No, the base stays the same. Okay? And subtract the exponents. Okay? Same idea for logarithms. If you said the log of R divided by S and base A, if you're dividing the numbers, you subtract the logarithms. The reason this was important way back when is they did not have calculators. If you had a choice, would you rather multiply or add? They would much rather add. Would you rather divide or subtract? Much rather subtract. Okay? Okay? So if you had something like, I'm going to say the log of 15 divided by 3. Okay? It's the same as the log of 15 minus the log of 3. And I'm just doing base 10. So if you divide the numbers, you subtract their logarithms. All this coming back? Remember it, kind of? Okay. Third law of logarithms. This one's laws of exponents. When you raise a power to a power, x to the m power, and raise it to the n power. When you raise a power to a power, what do you do with the exponent? Multiply them. So it's just x to the mn. So if I had like, even if I just say x to the 2nd power and raise that to the 3rd power, it would be x to the 6th power. Okay? And for the laws of exponents, it would be the log of r, and this author uses a c to the c power, base a. This third law, you move this out front, so it's c times the log of r. Okay? So if I had like the log of, let's say 6 to the 3rd power, I'm just going to do base 10. So you move that out, it's 3 times the log of 6. And I'm doing base 10. Okay? Now, like I said, the most important part of the notes is that change of base formula. Because all of a sudden the author is saying the graph, as an example, y equals the log of x base 5. You cannot just put that in on the calculator. Okay? You got to use the change of base formula. Okay, use the change of base formula. So, if I was going to do this, it's going to be the log of the number, so it'd be the log of x divided by the log of the number divided by the log of the base. Okay, that you can put in, okay, on your calculator and graph that. Okay, so let's go back. Let's go back to the beginning. I started it in exponential functions with the 2 to the x power. Now, if we wrote it y equals 2 to the x power, and we did y equals 1/2 to the x power, they were not inverses. Okay, but this is, if I did y equals the log of x base 2. Okay, so if I put that in, it would be the log of the number, the log of x, divided by the log of 2. Okay, so if we went back, that other one, first one, y equals, this would be the y equals 2 to the x power. Okay, now let's graph. Clear out that second equation. Leave the y equals 2 to the x power in there. And now in y sub 2, let's put in the log of x divided by the log of 2. And I'm still in Zoom decimal. Okay? And now I would also put in y sub 3. Y equals x. Okay, so you see the, okay, and if you need to go to Zoom Square, Zoom 5, make it look a little bit better. If you folded it over, that line, would one graph lie on top of the other one? Yes. Okay, so these two are inverses. They are symmetrical about the line. And there's a line right in there. Y equals x. So visually, you ought to be able to tell whether or not it's a function by a vertical line test, whether or not it's one-to-one by a horizontal line test, whether or not it's an inverse. Will it fold over the line y equals x? Okay? Okay. That's as much as we're going to do on that.